Hi everyone, it's Shem. Here's another video, this time about motorcycle suspension. I'm planning to talk to you about a number of different things, starting with what is SAG and how to work it out. Also why SAG is important and why proper suspension setup is important to your riding. As well as my own circumstances. So I'm gonna talk you through the reasons why I decided to change the suspension on this bike. And I'm also going to talk to you about why adding too much preload is not a good idea. And apart from all of these discussions that we're going to have, I'm gonna show you step by step how to replace the shock and the spring in your front suspension. So if you cannot be bothered to watch it all or you just want to jump to the relevant section, use the shortcuts in the description down below. Enjoy! Let's talk about SAG. There are two types of SAG. There is static SAG, which basically tells us what percentage of our suspension travel is compressed under bike's own weight. And there is also a dynamic SAG, which tells us what percentage of our suspension travel gets compressed under bike's weight plus rider's weight. Okay, so two types of SAG, static and dynamic. How do we go about working it out? Well, first of all, we need to take some measurements, okay? So we're gonna start by identifying where we're gonna take these measurements from. We need 2 points for rear suspension and 2 points for the front suspension. So let's start with the rear. I've already put a little mark here in the center of the axle because that's where I'm gonna be measuring from. And I'm gonna measure it from the center of the axle to the helmet log over here, right? So just, put your tape measure. I'm obviously not able to do it with one hand right now, but this is where I'm gonna be measuring from to, okay? So that's one length. It doesn't have to be there, but as long as you find 2 spots that are in the straight line above the wheel axle, then you should be right. And as long as you're consistent between your measurements and you always measure the distance between 2 spots, these 2 spots, you'll be fine. And same for the front suspension. You can either measure from the bottom of your seal up to, on the other fork leg it's easier, you can measure it to that edge over here, or you can measure it from the center of the bolt here to, let's say, to the fork crown over here. So it doesn't matter where you're measuring it, as long as you're consistent between the measurements and you're measuring in a straight line. We now identify the measurement points, so let's talk about different measurements that we're gonna be taking. So the first measurement that we'll need to take is a measurement of a fully extended suspension. Okay, so as you can see, I've got the bike jacked up in the center, so there is no weight on either of the wheels, and you can actually see if I move it, it moves, right? So the rear wheel is off the ground now. So I would take my first measurement of the rear suspension in these 2 spots and made a note of that. And I would do the same thing for the front. Take any weight of the front wheel, take the measurement and make a note of that. So that's step number 1. Another thing that we need to do, or the next thing that we need to do, is we need to take the measurement when the suspension is compressed under bike's own weight. So I would then drop it down. I'm gonna try to do it one-handed without dropping the bike on my head. As you can see, the suspension is okay. So we've taken that down. The bike is in the upright position. Not sure how well you can see it, but I'm resting a bike against a piece of board here. It could be anything. You can rest it against the wall or something, as long as it stays, as long as you can keep it upright. Okay. So I'm not sure if you could tell, but the suspension compressed when I was lowering the bike. So we now need to take the same set of measurements. Again, measurements of the 2 points that we've identified in the rear wheel and the measurements on the front. Same thing, okay? And make a note of this. You will know why later, okay? And the last measurement that we'll need to now take is with which means rider's weight with all the gear on. So helmet, boots, your normal riding gear, backpack if you're carrying one, and whatever else you might have with you on the bike, okay? You're not gonna be able to do it yourself, so it's best to get some help with it and get your friend or your other half to measure this for you. What I would advise is when you do that, you need to sit as close to the petrol tank as you can. It's a kind of typical motocross style sitting position where the center of gravity is closer to the front wheel, and you obviously keep your feet on the foot pegs. So you've got your gear on, you sit on the bike, you move it about a little bit front to back just to loosen up that suspension. Wait until it settles down. Once it's settled, you get your friend or your other half to measure the distance for you, both on the front and on the back, in the same location, in the same points that you were measuring before, and make a note of that. And now you've got all of the measurements done, and we can move to the next part of the video. You now know what the SAG is and how to measure it. So let's go through some numbers and see if we can calculate the actual SAG percentage. Because we all have different bikes, i.e. you might have a rally version of the bike and the suspension travel is slightly different on the front and on the back, I've just used some generic numbers here just to illustrate how to calculate the SAG. So this don't necessarily correspond with anything on our bike, but the math is right. So let's start with the measurements we've taken. So let's start with the first one. So the fully extended suspension, right? You've raised the bike up on the stand, you've decided on 2 points that you're gonna be measuring, and you measure the fully extended suspension, and let's just say, for argument's sake, that length is 600 millimeters, okay? So then you made a note of that, you're taking second measurement. So you're taking the bike off the stand, you're putting the bike under its own weight, and then you're taking that measurement between exact 2 points that you've measured before. Let's say you got 580 millimeters on that second measurement, okay? That's fine. Now you're putting all of the gear on that you normally ride with, and then you sit on the bike, you get someone to help you, you put your feet on the foot pegs, and then you try to stay upright or get somebody to kind of hold the bike for you, or perhaps rest the bike against the wall or something, but maintain the upright position, and sit, if we're talking about a CRF250L, try to sit as close to the tank as possible to get that sort of motocross sitting position if you wish. That's where the center of gravity should be if you're riding and you're sitting down. So you then take the measurements between the very same points and you get 540 millimeters, right? So you've got these 3 measurements, you've done the hardest part of the job. Let's do some number crunching. So to get your static SAG, so the bike under its own weight, we're subtracting 580 millimeters from 600 millimeters, and that gives us 20, okay? So your static SAG is 20 millimeters. In order to get your dynamic SAG, we're subtracting 540 millimeters from 600, and that gives us 60 millimeters, okay? So you've got 2 figures in millimeters, so you already know the length of your SAG. Let's now calculate SAG in percentages, because this is how usually people express it, so it can be compared for different bikes without knowing the suspension travel. As a suspension travel for our calculations, I've used an example of 200 millimeters, just to make the math a little bit easier. So let's work out static SAG. We know that from our previous measurements, we've got 20 millimeters of static SAG. So what we need to do is get 20 millimeters and divide it by 200 millimeters. That gives us a figure of 0.1, which when we convert it to percentages, gives us 10%, okay? So that's our static SAG. Now let's look at dynamic SAG. So very much the same principle. We're taking the figure of 60 millimeters, yep, and we're dividing it by our travel, so 200 millimeters, and we get a figure of 0.3. That's obviously decimals, so when we express it as percentages, we get 30%. So based on that, based on our example, our static SAG is 10% and our dynamic SAG is 30%. So you now know how to calculate it for your bike. The math is exactly the same. You just need to obviously do your measurements and use the travel of your either front or rear suspension depending on what you're calculating. So yeah, that's pretty much it. We now know what the SAG is and how to work it out, so let's discuss why SAG is important. Let me start by saying that the main role of the suspension is to maintain wheel's contact with the surface that you're riding on, okay? Because if that contact is maintained, you are able to turn when you need to, and you are able to brake when you need to, and so on, okay? So that's the main purpose of the suspension. So let's discuss it in terms of SAG. So let's go from one extreme example to another extreme example. Let's just say that you don't have any SAG whatsoever, okay? So you've got so much preload or such a hard spring on your suspension that when you sit on the bike it doesn't compress at all. Okay, so forgive my bike drawing, by the way. I've done my best, as you can tell. So the bike is going at speed, let's say 30-40 miles an hour, okay? The bike then hits a pothole over here. It doesn't have any SAG. So what happens? The bike, because of the speed that it's going at, is trying to move forward. So the wheel will go like this, okay? There isn't any negative travel, there isn't any sag in there for the suspension to decompress. So the wheel will end up being in the air because the bike is going at speed. And what happens there? Well, the wheel is in the air, so if you need to brake or if you need to turn, you cannot. Again, this is not ideal. This is why it's always good to have sag, okay? So that's the example of what happens when there isn't any sag, or there is very little of sag. So let's now see what's gonna happen if the sag is set up properly. So let's say you've got 30 to 35% of sag. So you're going at speed, again, same situation, you're about to hit a pothole, and what happens? The bike continues to go forward, and it's about to, well, it continues to go forward and it's pretty level, okay? But now you've got some negative travel in the suspension, so your suspension is able to decompress, and as you start hitting that pothole, the wheel is pushed down, okay, by your suspension and maintains the contact with the surface, which means that when you need to brake or when you need to turn, you've got that ability, okay? So that's when the sag is set up properly. Now what happens if you've got too much sag, as I did when I got this bike with its original suspension? So imagine, same situation, bike is going at the speed, we can get rid of that now, okay? And it's getting to this point and we're hitting an obstacle, okay? Because you've got so much sag, you've got very little of your suspension travel left to play with. So you're hitting that obstacle, okay? Your suspension compresses, you went through the travel because you've got only, I don't know, maybe 60 millimeters of travel left, okay? And all that force from hitting that obstacle gets transferred to your handlebars and your bike gets launched into the air. Okay, so that's not an ideal scenario because having too much sag obviously limits how much suspension travel you've got. So it's always good to set up a sag to compromise between the positive and negative travel. And from what I've read, people usually recommend for adventure riding for sag to be between 30 to 35%. Okay, so this is why sag is important. Right, we've covered the suspension basics now, so let's discuss my circumstances. I'm gonna start by saying that in general, I prefer not to change stock components. And the reason for that is that I believe that manufacturers spend significant amount of time and effort developing each component to achieve the best compromise between its costs, performance, weight, strength, and so on. However, there are some exceptions to it. And one of these exceptions is suspension. When a manufacturer like Honda releases a bike like the CRF250L, they do a lot of market research to identify first where they're gonna sell most units of that particular bike and what type of riders and what type of conditions are in that particular market. And because of that, I don't have any evidence to support it, but this is my belief based on what I understand about this bike. Most of those bikes will be sold in markets like Thailand, when the riders are a lot lighter and a lot shorter than, for instance, riders in Europe. And because of that, Honda tailored that bike to work the best in that market. But by doing so, that means that the bike doesn't necessarily perform as well in other markets when you've got heavier riders, taller riders, and so on. And you can clearly see it from these figures. So if you have a look over here, my weight is 85 kilograms, which I'm pretty sure it's heavier than an average rider in places like Thailand. On top of that, I normally carry about 11 kilograms of gear on me. So jacket, trousers, boots, helmet and so on. So all of that adds up to 96 kilograms. So the total rider weight is 96 kilograms. Then on top of that, I've got accessories on the bike which weigh 11 kilograms and they pretty much stay on the bike all the time. So I've got bark boosters, skid plate, pannier racks, then I've got a petrol can and so on. So that's additional 11 kilograms of weight that's on the bike. So when I initially purchased the bike, I didn't really change anything in terms of suspension, and of course you're limited as to what you can change. The bike only allows you to change the preload on the rear shock. Other than that, there are no adjustments in the suspension. So with the stock settings, which was pretty much no preload, when I measured the sag of the bike with me on it, it was 59%. So the dynamic sag with all of that and my rider weight with all the gear on it, 60% of travel. So that's crazy. I mean, this is a clear evidence that the bike wasn't really tailored for this market, because I mean, this is excessive. I was expecting to get probably 30, maybe 35% max of sag, and I got 60. So the next logical step for me was to add a little bit of preload. So I've checked how much you can actually do, and there is limited amount of preload you can add on the stock shock. The thread is very narrow, so you can maybe add about 6 millimeters of preload. So I've done that, and that took down the dynamic sag to 50%. But that was still way more than what I wanted. In terms of front wasn't too bad in terms of numbers. I would probably expect the dynamic sag to be about 25%, maybe 30 at max, but it was slightly more than that. The numbers weren't too bad, but the fork felt quite soft. If it was just the suspension softness, it probably wouldn't bother me that much. However, the bike bottomed out way too often, both at the front and on the back. And I admit, I'm an inexperienced off-road rider, so I'm not as smooth as I could be. However, still, I didn't feel that bike should have bottomed out in certain circumstances, and it did. And that, combined with this number over here, indicated to me that for my riding style and for my rider weight, I've got a bit of a problem with the suspension. The objective here is to increase the suspension stiffness and reduce the sag. So there are a number of ways that we can go about it. The main problem on this bike is the rear suspension. The front is a little bit of a problem, but the rear is more so than the front. So let's start with that. You could potentially increase the preload, if you could, like put some extra washers in and so on. But increasing preload isn't necessarily a good idea, especially if you have to increase it by a lot. And I'm gonna talk about it in the next section of the video. But for the time being, I just want to say that the best way to mitigate this issue would be to change the spring on the rear shock. The problem with that is that when you change the spring and you increase the stiffness of it, if your shock doesn't have any adjustments, your shock will be imbalanced, in a sense that by putting a stiffer spring on the standard shock, all the valving in the shock will be tuned to cope with the stock spring. So like a compression damping and the rebound damping, that will all be set for the stock spring. So by putting stiffer spring, you're losing all of that tuning. And if your shock isn't adjustable, you might come across some issues. So because of that, my thinking was, instead of just getting a different spring for my rear shock, I will just replace the whole shock. In terms of front, because the front wasn't as much of the problem as the back, I thought I can get away with just increasing the spring rate by a little bit. There is a, I think, certain percentage that you can get away with it. It's something like 10, maybe 15%. If you increase it by this much, you can still probably get away with the change of spring as opposed to having to revalve it. So yeah, I thought that would be the best idea to tackle the problem. The question is, what to get. So because Honda CRF250L has been on the market for a while now, there are a lot of aftermarket options to choose from. And if money is no object, you can go for something like Racetrack suspension in the USA or All-ins in Europe. Both of these businesses do top of the range suspension, but quite pricey. I did not buy a budget bike in order to splash £1,500 on the new suspension, so I wanted something in between, something that's better than stock, that will allow me to set the suspension up correctly, but not necessarily top of the range suspension. You know, I'm still learning, I like the bike how it is, and you know, I don't really fancy spending an extra £1,500. So I found a company called YSS, and they are made in Thailand. I think they are based in Thailand, and they also make their shocks in Thailand. They've got full range of shocks for different bikes, and I bought their budget shock for the CRF250L. I think I spent something like £250 for it, so significantly cheaper than all the other options that I mentioned. In terms of front suspension, I found a set of springs. I don't remember the business name. I'm gonna put it in the description. And I think they cost me something, sorry, I said set of springs. It's only one spring in that shock, so I bought a replacement spring for the stock spring, which is slightly stiffer than the original one, and I paid something like, I think, £50 for it, so, you know, not excessive. All in all, I've just spent 300 quid, 250 for the back and 50 for the front, so, you know, not a big ask, I suppose, in comparison to spending £1,000 or £1,500 on the all-in suspension. Not that long ago I mentioned that adding too much preload is not a good idea, and I would like to illustrate to you why that is. But before we even start with that, I wanted to talk about linear springs. And linear springs is something that most manufacturers fit into their suspension. And what that means in practice is that, for instance, if you have a spring rated at 100 newtons per millimeter, is that for each millimeter of spring compression, you need to apply additional 100 newtons. So for first millimeter, let's say we're compressing spring by a millimeter, we need 100 newtons of force. We want to compress spring by 2 millimeters, we need 200 newtons of force, and so on. So that's what it means when a spring is linear. So if we move to the to our graph over here, on the left axis you've got spring force in newtons, and it goes from well, the first mark is at 1000, 2000, 3000 and so on, and on the bottom axis you've got spring travel or spring compression in millimeters. I've tried to do it to scale, but it might be a little off in places. I've also tried to use the example of the springs, of the spring that we've got on the stock suspension on the back. So I think that spring's got about 60 millimeters of travel. It might be slightly more than that, but it should be round about there. So you've got from 0 to 60 millimeters, and that represents the spring travel on our stock CRF250L. So if you look at the blue line over here, the continuous blue line, that represents the stock spring on our bike, and I believe the spring is rated at 93 newtons per millimeter, which means that for each millimeter of spring compression, we need to apply an additional 93 newtons of force. So as an example, if you want to compress the spring by 10 millimeters, you need about 930 newtons of force, and so on. And then if you want to compress the spring all the way, so to 60 millimeters, you need about 5,500 newtons of force. So that's when the spring sort of bottoms out, or where your suspension bottoms out. Okay? So look what happens when you then take the stock spring and you apply preload. So I've used the example of preload that we all can adjust on the stock shock, which is about 6 millimeters. So for each millimeter we are adding additional 93 newtons of force, of preload force. So by 6 millimeters you've got something like 558 newtons of preload. So let's round it up and for argument's sake it's 600 newtons of preload. Okay, so we're here. You can see that the blue dotted line is the stock spring with preload on. So it starts at about 600 newtons of force, and you can see the whole line moved up. So yes, you've increased the resistance to bottoming out by 600 newtons because you apply that preload. So yes, the suspension will be stiffer, it will bottom out less, but you've also created something that wasn't intended, which is the lack of sensitivity for the small bumps. I mean, maybe not with 6 millimeters, but with higher level of preloads, you can really make your suspension insensitive to small bumps. And if you look over here, that spring starts at 600 newtons. And what that means in practice is that in order for your suspension to move the first millimeter, you need a force greater than 600 newtons. Whereas if you look at the stock spring, in order for it to move the first millimeter, you only need 93. So if you take it to an extreme example and you apply 20 millimeters of preload, if you could with the stock shock or something like this, that means that in order for the suspension to even move a little bit, you need something like 2000 newtons of force or something along this line. So this is why it's not ideal to apply a lot of preload. It should be used only a little bit, but not more than, few millimeters. If you need more than, 5 millimeters on preload, it's probably time to change your spring. So also on this graph, if you look at the red line going up here, this is the new spring that I purchased for this bike. So not only spring, it also comes with a shock, but for argument's sake, purely to illustrate the point, this just represents the spring. So this spring is rated at 120 newtons. It means that for newtons per millimeter. So it means that for each millimeter of spring compression, we need to apply 120 newtons. Okay, so if you look over here, this massively increases the bottoming out resistance. So at 60 millimeters of travel, so fully compressed spring, we need something like 7,200 newtons of force, okay? So it's significantly more than the stock spring, and it's significantly more than the stock spring with a preload. However, when you look at the very bottom bit over here, in order for the spring to compress that first millimeter, you only need 120 newtons of force, not 600 as you would need with the stock spring and the preload. This is why it is so important when your suspension is too soft, you need to consider changing the spring and not increasing preload by a lot, because that kills your small bump absorption sensitivity. So yeah, I'm hoping that makes sense. If it doesn't, just write it down in the comment section and I'll try to do my best to help you out with it. Right, let's begin. So manual states that you have to remove the seat, remove the rear subframe and so on, and it's all well and good, but I think there is a quicker way to do it. So I've seen people on the internet doing it, and I'm gonna attempt that way. I think in order to access the rear shock top mounting bolt, we're gonna have to remove the brake reservoir, and then we're gonna have to remove the fairing on this side of the bike just to be able to see the other side of the bolt, and then we're gonna have to disassemble the linkage down below in order to slide the shock back down. So let's do it. Right, so we got to the tricky stage now. In order to disassemble the mounting of the shock at the top, we need to access that nut in here. Not sure how well you can see it. I'm gonna put a torch in. Yeah, you should be able to see it over there. So in order to do that, you just need to get the spanner size number 17 and try to slide it behind, and that will prevent the nut from spinning, and then you're gonna unscrew it from the other side. Okay, so now we need to access the bolt on the other side of the shock. So I've got a bit of an extension on the ratchet. It's size number 14, and the spanner has already been inserted on the other side. So I just need to loosen that up and hold the spanner while I'm doing that. Okay, I'm getting the smaller ratchet in now. There's a lot more torque required than I was expecting. Manual states 44 Newton meters for that, so I'm really surprised how tight it was. Unless they put a Loctite on it, it's quite possible. So here are two shocks side by side, and you can actually tell just by looking at it that YSS Shock, it's much more premium. It's all CNC machined. It looks better than the stock shock, and if you actually look closer, the oil container, it's a bigger diameter than on the stock shock, saying that it's slightly shorter, so oil volume it's probably similar. However, the shaft, it's got a bigger diameter than on the stock shock, which is good. And obviously you've got a rebound adjuster over here, which you don't have any adjustments apart from preload on the stock shock. So overall it looks like an improvement. And I also checked the weight of both shocks, and this is about 3.5 kilos, and this is just over 3. So you're gaining, well, you're losing 500, well, just short of 500 grams of weight, which is great. One thing I forgotten to mention is the length of the shock, and it's the distance between the mounting center of the mounting point, so eye to eye length. And the stock shock is 396 millimeters, whereas the YAS as it came out of the box, it's 382. So there is a 14 millimeter difference between the two, which means that if you fit the shock as it is, if you fit the new shock as it is, it will lower your ride height by approximately 50 or 60 millimeter, because the shock will go through suspension linkage, so the 12 millimeter will actually be multiplied by whatever the ratio of the suspension linkage is. So in order to mitigate that, we have to adjust the length of the shock, and luckily the YSS shock is adjustable, so we're just gonna have to release that locking nut here and unscrew the top mounting bit. So let's do that now. Okay, so we've actually I've put a bit of Loctite in here and we've tightened it up. Upon measuring the distance between the eyelets, the shock with the maximum extension, which manual states you should not extend it above that, so you can, as soon as you see the little hole here, you should stop extending it, which gives you about 10 millimeter extension. So we've got a total length of the shock which is 4 millimeter shorter than the stock shock, which means that we're gonna lose about 12, maybe 14 millimeter on the rear wheel. So not much else I can do about it. Just gonna have to accept it and fit the shock as it is. Shock is ready to be installed. Before we can put it in, because it's slightly larger than the stock shock, I've lowered the jack, which brought the suspension up, which gives me more space between linkages. It's tight, but you can still feed it through there. So we're gonna do that. And then once you're through, you're gonna have to align the shock with the clamp at the top, which I've now done. And not sure if you can see it very well, but it is indeed aligned. So in order to hold it in place, I've got a bolt, a stock bolt. I've put a bit of lube on it. You don't really need to, but there's no harm in sort of adding an extra corrosion resistance to it. So I'm just gonna put it through, but not all the way yet. I'm just gonna put it through enough so it holds the shock in place. Okay, so I can let the shock go and it stays there. So now we're gonna go to the other side, and I've already prepared assembly. This is the nut that clamps that on the other side, and it came with a washer. So in order for me to be able to fit it in there in such a tight space, I put a very little drop of super glue between the washer and the nut so it all stays in one place. And then I put a bit of a tape in the spanner in order to create a tight fit. So I'm gonna be able to slide it through and then put that bolt in. Okay, we're on the other side with the washer attached to the nut. As you can see, there is a bit of tape in there that is holding it in place, which will hopefully allow me to insert it in and align it with the hole on the shock mounting. Okay. And then I'm gonna go to the other side of the bike and start turning it so the thread catches the nut. I'm gonna torque up the this bolt on the shock now. It's 54 Newton meters. So I've got a torque wrench here, and I still got my spanner on the other side. Then we're gonna put the brake container back on. Okay, so with the fairing being back on the bike and with the brake container being installed, it's now time to put back the bottom linkage. I've already dropped or raised the bike up slightly in order to align the hole in the shock with the hole in the bottom suspension linkage, and as you can see, they are now aligned. I've got a bolt for that. I've put a little bit of grease there for an extra protection. And we're gonna put it through. One thing to note, for some strange reason, the aluminium bit where you mount the shock on the other side, it's threaded, but it's an aluminium thread, and when you actually try to torque it up to the correct specification, you just rip the thread apart. So I don't know what's the point of having it there if you've got a nut on the other side anyway. So I'm gonna put it through, try to torque it up to 44 Newton meters as per the manual, and if the thread goes, it goes, and I'll just stick the nut at the end as it was with the factory shock and take it from there. So let's do that. Yes, as anticipated, despite the thread being in there, it's probably damaged it because I cannot even tighten it more than that. It just keeps spinning. So I don't really have a clue why they decided to put a thread on the other side, because it really needs to clamp that bush strong from both sides, and having thread in aluminium is really not ideal. So I'll just put a factory nut on the other side and torque it up to 44 Newton meters. Okay, that's aligned. So I've already got that long bolt. I've put some grease on it. You can, despite the bike having very few miles on, you can already see the corrosion on it. So there's no harm in putting a little bit of grease on it. I'm gonna stick it from the other side, and then again put the 19mm nut on. And not sure if you can see, but these nuts, they've got a locking system, so they should not come off, otherwise I'd be putting a Loctite on them, but I've got that piece of metal here that keeps them secure. So yeah, let's put that on. And the bottom one is 44 Newton meters as well. Okay, that's done. Okay, so with the rear suspension being done, it's time to do the front one. And this bike has the spring in the right fork leg, so we're gonna have to release the clamps and drop it down. Obviously I've got a screen here, so I'm gonna have to take that off from here as well, and then before we do all of that, I'm gonna have to take the front wheel off in order for me to be able to remove that fork leg. So let's begin. I've not shown it on the video, but before I remove that off the bike, I loosen the top cap. Otherwise you'll struggle to do it in a vise like this, so it's better to do it when it's clamped on the bike. Just loosen it up slightly, and then the rest of it you can do here. Just you have to be careful because it's loaded. In order to actually access the mainspring, you have to compress the fork fully. You can see the bottom of it is resting on a jerry can here, and then press down on it, and that will allow you to take out the spring clip, which you can see over here. It sits in the groove, and it's absolute pain in the ass to get it removed. So you just have to be patient with it and possibly get someone to help you, because there might be a technique to do it, but if there is one, I don't know it, but I've managed to do it anyway. So yeah, so far that was probably the most difficult bit. So now we're gonna remove it and take the mainspring out. Because the bike is relatively new, I'm gonna reuse the oil, no point changing it after a few hundred miles. So I'm gonna take it up slowly and let as much oil drain as I can from the spring down. And then I'm gonna put it aside, and I've got some spare oil here that I can always top it up, so that shouldn't be a problem. After removing the spring, I've measured the distance from the top of the fork to the oil surface, and it turns out that it's 190 millimeters, which is very different to what I've got in my Honda manual, saying that the manual is for the bikes from 2013, at least that copy that I've got, so it might not be right. The manual states 122 millimeters, so there is a 70 mil difference between what I've got here in the manual and what I've got in my actual fork. So I'm not gonna worry about it too much. Maybe something has been changed over the course of 7 years. My bike is 2020, so it's quite possible. I'm gonna proceed with the installation of the new spring, which is this one here. I'm not gonna bother topping up any more oil, because whatever I've lost when I taken the spring out, it's probably less than a centimeter of oil, and the new spring it's got a slightly thicker coils, so that will kind of account for this displacement of oil. Okay, so we're gonna just tighten it, just to seal it. I'm gonna do a final tightening once it's on the bike. We're ready to put the fork leg back into the bike. We're gonna start by inserting it in and clamping these two. I think the manual states 32 Newton meters clamping force, so we're gonna do that first, and then we're gonna put the wheel back on, and then we're gonna put the axle through, torque gauge to 73.5 Newton meters, and then the pinch bolts are 20 Newton meters each. The final thing left to do is just to torque up the top clamp of the fork. So it's 35 Newton meters according to manual, and I've actually managed to put a 30mm socket on top of it. So I'm gonna put my torque wrench here and the job will be done. Before I take you through the results, I just wanted to give you a little update about the shock length. I wasn't quite comfortable with the length difference that I discovered between the stock shock and the YSS shock, so I contacted the place where I bought my shock from, and they contacted YSS on my behalf, and it turned out that according to YSS database, up until 2017, the stock shock length on the CRF250L was 395mm, and then from 2017 onwards was 380mm. So when they provided me with a replacement shock for my bike, and my bike is I think late 2019, when they provided me with a replacement shock for that bike, they sent me a 380mm long shock. So that's where the difference came from. For some strange reason, my bike has a shock which is the stock shock on the bike was 395mm, which according to YSS database, it should have only been on the bikes up until 2017. So I'm not quite sure what's going on there. Either they fitted my bike with the old shock when they were assembling it, or YSS database is incorrect. Either way, something's changed, and my advice would be, if you're ordering a new shock for your bike, take your stock shock out and measure the eye-to-eye length just to be sure. I mean, I don't think there's gonna be much difference between them. I don't think the travel has changed. I think it's just the difference in the stock shock length. So I'm probably not gonna bother changing it for a longer one. Nonetheless, just to be on the safe side, I would definitely recommend taking the stock shock out and measuring it if you're planning to do it, definitely before you order a new shock for your bike. The new suspension has now been fitted on the bike, so let's go through some numbers before I give you my riding impressions. So let's look at the front. Stock spring at the front was 7 newtons per millimeter, or round about there. I had 34% sag with it, and I felt that the suspension was a little too soft at the front, and it was bottoming out too often. So I've replaced it with the 8.5 newtons per millimeter spring, and with that I've measured the sag of 25%, so a good improvement there. Now let's look at the rear. The stock shock was 93 newtons per millimeter with a spring of that value. I had 59% sag with that spring, and then by adding as much preload as I could on the stock shock, I've managed to get it down to about 50%, which wasn't enough because the bike was bottoming out way too often than I would expect it to. So it's been replaced with the new shock, which came with the spring of 120 newtons per millimeter, and that gives me a dynamic sag value of 33%. So huge improvement, and exactly how much sag I wanted to have on the back. Okay, so looking at these numbers, you might be wondering, well, you know, if you look at the stock spring at the front, the values of the stock spring in terms of sag are very similar to what I get with the new shock on the back. So you've got 33%, 34, 16, 17, so they look very similar. And on paper, yes, they do. But when I sat on the bike and compressed the suspension and then I let it decompress, they felt imbalanced. So I've tried just installing the new shock on the back and leaving front with a stock spring, so as it was, and that didn't feel good. So when I've been compressing the bike, like front was compressing more and at the different rate than the back, and then when the suspension was coming back, they were coming back at different rates, so they felt like it basically felt like there wasn't a very good match between the front and back. So I decided to fit that new spring and see how that felt, and I'm pleased to report that now the suspension feels a lot more aligned. So with the new shock on the back and new spring at the front, it seems to be working together better. So the bike compresses at the same rate and decompresses at the same rate too. So it feels balanced. Okay, so let's go through some riding impressions. So how does it feel? Well, so far I've done about 600 miles on it with the new suspension, and quite a lot of it was done off-road in the mixed terrain with some difficult sections too. And I'm pleased to say that the suspension is doing miles better than the stock suspension, at least for what I wanted it to do. So I'm gonna start by saying that when you hit obstacles at speed, let's say you're going 30-40 miles an hour or something like this, with the old suspension, bike used to develop that kind of strange boaty behavior when it was kind of floating and bouncing like this, and it wasn't very stable. With the new suspension, it feels a lot more composed. The bike seems to be moving forward, and it's a lot more stable as opposed to kind of that boaty feeling, if you wish. So in my eyes, that's an improvement. Another thing that I want to touch on is bottoming out, because that was one of the things that was annoying me on the stock suspension. It bottomed out way too often in the terrain when I would not expect it to bottom out, and so on. With the new suspension on the bike, it doesn't bottom out nowhere near as often as the stock suspension. I mean, don't get me wrong, if I jump off something high, or if I hit something at speed without kind of accommodating that with my body, you can still bottom out the suspension. I mean, you can pretty much bottom out any suspension, but it feels miles better than the stock suspension for my riding style and for my weight. And another thing that I wanted to mention is how easy it is to lift the front wheel. So some of you might know I'm a beginner in terms of off-roading, and I'm learning how to lift the front wheel in order to go through larger obstacles, or how to do small wheelies and so on. So I've been practicing that with the stock suspension, and I've been having rather hard time. I could lift the front wheel, but it required to adding a bit of throttle, releasing the clutch, moving the body, and so on. So it was doable, but a lot of that energy and effort that I put into it used to go into the suspension compressing, because it was so soft. With the new suspension in place, it is miles better. Now, in order for me to lift the front wheel, it's enough for me to actually just compress the suspension, move the body backwards, pull the handlebars a little bit, and add a little bit of throttle. And when you combine it with going, let's say, at speed, and you just want to lift the front wheel just ever so slightly to make going over an obstacle easier, this is so much more doable than on the stock suspension. So that was one of these things that I never even considered, but it had huge impact into how I ride the bike, and how easy it's gonna be, how much easier it's gonna be for me to learn to control the bike better. So that's these are all kind of riding related benefits. There is one more thing that used to annoy me with the stock suspension, and that's when you move the bike around and you've got your side stand out just as an additional security, and the suspension was so soft when I was moving the bike around, the side stand was catching the ground, and it was kind of throwing the bike off balance. So with the new suspension, obviously the bike sits higher up, and the stand doesn't touch the ground anymore, which is a great thing, because when I move the bike around, it's one of those things. It used to be annoying, and it's not, which is great. I've not even thought about it when I was fitting the new suspension. So all in all, I'm really pleased with the results, and if your riding style is similar to mine, and if you're considering changing your suspension, I would definitely recommend it. It's probably best £300 that I spent on this bike so far, because it made a huge difference. So thumbs up from me. Thank you for watching. I appreciate it was rather a lengthy video. So if you've got any comments or questions, write them down in the comment section down below. I'll do my best to answer them. Other than that, see you in the next video. Enjoy your riding.